Hello and welcome to my channel. Today I'm going to be covering how to design this Mini-Kosell carriage, or I'm sorry, Mini-Kosell effector in FreeCAD part workbench. This particular one was done in the part design workbench using Sketcher, but due to some problems with the polar array, I was unable to recreate it, even though I was able to create it the first time. So I will show you some of the sketches used to make this, and then I'll show you the part workbench. So here I have opened a version of a recreation. I tried to recreate the first one that I made, and what you'll see is I'll try to show you real quick how the polar array is not functioning as I would expect. And I've tried many different ways to get this to work, but in this version of FreeCAD, which is the daily build of version 1.17, I'm unable to get it to work. So it's, I guess, unstable maybe at this point, but that's part of what you get with using the daily build. So I'm selecting the body. You can see it's selected by the blue line there. I'm going to select this pattern. So you can see, oh, I already have yeah, so I was able to do a polar pattern for these parts, but watch what happens when I try to do it for this is this additive loft. And it doesn't matter that, like, you might say, well, it's not at the tip. It really doesn't matter. I've moved this sucker around 100 ways to Sunday and it still doesn't work. In the current version, I imagine once this gets a little bit better, it'll be awesome. So I'm going to try to do a polar array with this, and I'm going to show you it's going to be with 3 occurrences. And you see when it doesn't intersect support, it shows it as red, which I love. And so what I'm going to do is I'm going to select the Z-axis so it transforms it to where I would expect it to have support, and you see it still doesn't find it. So so one of the things I used to do in the past was, one of the things I did to get the other one to work was to move this base of this sketch just a tiny bit into the object, like a 1/10 of a millimeter or less, and that did it, but that's not working anymore. So let me show you. So that's why I'm not doing it sketch based, even though I'm a fan of sketch based. And let me show you the sketch I did for this. So I think this is worth noting, and this technique is interesting because this sketch doesn't link to any external geometry. And the way I did was replicating some of the external geometry with construction geometry. So the side of this is 31.5, so it's the same as the circumscribed radius. And then I constructed both of my cutouts to create that external geometry. And that helped in getting the measurements for doing the part design workbench. So to create this shape, we're gonna do a new part design workbench or a new document, and we're not going to create a body or an object because we're going to be using part workbench, and that doesn't require a body or an object. So we're going to start out by creating a parameterized geometric primitive, and we're going to create a prism, and it's going to be 6-sided. Its circumradius is going to be 31.5, and its height is going to be 8 millimeters. So this creates the basic body of the shape. And we'll close this. And that's the same as in Sketcher. I would have done that with an octagon and then padded at 8 millimeters. So now we're going to add the main body of this, and so we're gonna be adding this piece and this piece. So you see that creates these 2 cutouts. So the way that's accomplished is, first I want to orient in the Y direction. So that's if you hit 2, that gives you the top view. And we're going to just add, let's go down here, we're just going to add a cube, and we're going to add a prism. So the prism can be added from here, and prism. The prism is going to be 12-sided because that gives us the angles that we want. And it's going to be, the circumradius is going to be 27.4. And I'm not going to go into how I got that at this point, maybe in another video. So create that. So you see, maybe it's obvious why it's 27.4. So now we're going to move these into the correct position. So we'll start with a cube and move that into the correct position. So that keeps it visually similar. So now we're going to move this cube, let's see, in position. First we're going to move it in the Y direction down to the edge here. And it's just going to be, so that brings it right to the edge. And we want it 1, 2 over. Okay. And then we're going to move it in the X direction. We're going to move it, we want this centered. It's 12 wide, so we move it to -6. Okay, so that's an easy centering. So that's the position we want. The depth of this is not really very important. It's an axis to in here will be the nuts. So for this prism, first we're going to rotate it by 30 degrees, or I think actually 15, half of 30. So the angles on each of these sides between the segments is 30 degrees. So I wanted it just oriented correctly. So now we're going to move it in the Y direction. I think it's 51.5. Oops, that's the wrong direction. Oh, that's that's the angle. We don't want that. We want the position. So let's move it in the Y direction, and I'm just going to type in 51.5. Oop, that's Z. I'm full of mistakes. Sorry. So let's try this one more time. All right, so 51.5. And that's not correct. What did I do? So we want it right there. 48.5. I don't know where I got 51.5 from. 49. Okay, sorry for that. So the position, it ends up being 48.75. So we look at this 48.75, and that gets the intersection on the corner and on that flat plane. And what that ends up leaving is 10 millimeters line here, which is what I wanted. So that corresponds with that. So this is our basic shape so far, and you'll see how it ends up is like that. Now that our shape is closer to where we need it to be, so let me highlight this. Let's go in. There's the cube we just created, or similar, and there's the prism that we created. So that's what we're replicating here. So we're going to do a Boolean subtract of this main object, subtracting this prism, and then we're going to do a second Boolean subtract of this object, subtracting the cube. And this is our basic shape that we'll be copying and rotating. So to create an array of these around, the polar array could work, but what we're going to do is we're going to do a simple copy. First we're going to create a simple copy, then we're going to highlight it and do a transform, because in this shape, in this sense, you don't need the degrees end up being right dead on, because we're working with 30-degree objects here. Oops, went one too far. Let's go back. Or one too short. We want it there. Okay, let's create another copy. Do part, create simple copy, and we're going to transform this as well. And that one's going to go right here. So we have all 6 sides with their cutouts. And now we're going to do an intersection of all 3 of these shapes to get our main body, our final main body. You can see it was all the cutouts here. Later on, we'll be adding standoffs for the rod arms, cutouts for the nut access. We'll be rounding off these edges. We'll add a polar array of through holes for mounting the hot end, and we'll be adding a cutout for the hot end. So at this point, I want to kind of check my measurements to make sure I've got everything right. So I'm going to go over to Drawing Viewer, where I've placed a sketch of my object, and I'm going to make some measurements. So I want to measure this distance. I think it should be 31.5, and it is, so that's good. So to get my target is a 40 millimeter distance between these 2 standoffs. So with 31.5, I only have 8.5 left. So the standoffs are going to be 4.25 each. And maybe just 4 so that there's clearance. I don't know. The next bit I want to add is the standoff for the rod ends. And that will each plane will have one standoff. So let's start by orienting this from the overhead view. So we're going to want to orient the cone. It's a cone-shaped standoff. It's going to be oriented on this axis and plane here. So we're going to add a cone and a cube because we're going to combine those two to make our shape. And we're going to start by rotating the cone on the y-axis. We use the transform to do this, the transform tool to do that. We're going to rotate it on the y-axis by 90 degrees. And you'll see that orients it to this plane. So now let's get rid of this main body so we can see what we're doing. So we're orienting it to that plane. Now let's set the size of the cone. And the radiuses are going to be, we're going to leave that at 2. We're going to set this one to 8. And we're going to set this to 4.25. And if you remember, I think our main body was 39.5. So this, or no, it was 31.5. So 8.5 plus 31.5 is 40, and that's our target distance there. So that's all we're going to do for the cone. Now let's change the cube to suit our needs. We're going to change the length of the cube to 4.25. And we're going to set the width and the height to 8 millimeters. Now we've got to position the cube so that it intersects correctly with our cone. And I'm sorry, I think I set these wrong. So it's going to be, we want the height to be, no, that's correct. All right, I'm sorry. So now we need to change our position of our y-axis to -4 and our z-axis to -4. And you see now that how it intersects correctly with our shape. So we need to change. Okay. So that's all the construction. Now we're just going to do the intersection of these. And that's going to be our final basic shape for the standoff. There'll be a hole here eventually. Next, we need to position it on our main body. So to start, to position it on our main body, I'm going to move this up 4 millimeters in the Z direction. So that gets it on the correct plane. And I think it'll be, let's see, we're going to move it in the X direction, and it's going to be 30 something. Nope. 20. I think that's correct. Move it down on a Y, and this is why I worked on this plane, because it was parallel to the y-axis and tangent to the x, and so it just makes it a whole lot easier for lining this first one up. Okay, so I think it's going to be 23.5 or 25 or 23. So let's try 23.5. Nope. 22.5. Nope. Okay, so So to line these up perfectly, I'm going to use the draft move. I've already set the working plane to this plane right here, and I'm going to select, just a bunch of the different line tools, and let's select this object. Let's do a draft move, and let's see if I can get the center of this. So that's selected, and let's move it to the center of that. So that lines up our shapes perfectly, and let's do the other one over here. We'll do the same thing, draft move, come up close to get our midpoint there, and select it to our midpoint there. So that's good. That's good enough for our. So now we'll do an array copy of these two shapes. We'll do one at a time, and the array copy is in part of our draft tools. We're going to do a polar array. So we pick the array, and let's change the type. You already see we've got an array there. We're going to do polar instead. And for the polar, we're going to change the number of polar to 3. It defaults to 1. And you see there we've got our array there. And this is similar to what I would do with the polar array in Part Workbench, but that seems to be broken for me right now. So now I'm going to create a second array the same way, and we're going to do array, and we're going to change it to array type polar, and change the number to 3. And there, so there's our shape shaping up. Next, we're going to add a through hole for the rod bolts. So we're going to do that by adding a cone. So let's go back over to the Part Workbench. We'll add a cone, and that's what happens when you don't turn off your draft grid. So let's turn off the draft grid. I wish it didn't do that, but there's our draft grid there. So now let's get back our view. Okay, so we've got in part design, or in part, I'm sorry, we've got our cone, or our cylinder, sorry, and we're going to set the radius because I want this is going to be a through hole. It's, I think, a 3 millimeter, so it's going to be 1.5 is the radius, and we're going to set the height to the distance we want these to be, and that'll be a sort of a check and balance. So it's going to be a 40 millimeter cylinder. Let's transform it flat, so 90-degree transform, and let's get our view like this so we know. So again, I'm going to work with this bottom edge here because it's already parallel with an axis. So now let's transform this, and I think it should be 20. Let's do this by hand so we can see it better. So let's do axis position, and in the Y direction I think it's going to be 20. So now you can use your scroll wheel for this as well, because the reason why so it's not 20, so that's a problem, because I think this from center is supposed to be 20. So let's so it's 23.5. Let's try. Yeah. So let's change it to let's raise it in the Z direction, 4 millimeters. And all right, so that's not center. So let's try 23. Is it going to be 0.25? Nope. Okay, so what I'm going to do is I'm just going to well, let's move it this way. I'm going to use the draft workbench to center that, and that'll kind of tell me where I've screwed up. Now it would be just a whole lot easier if you just, all right, so that's good. So we have our little bit of clearance at the end of those. So it's just a little bit under 40. So I like that. So let's move it, get that. Oh, it is in the center. Okay, good. So that was just a visual appearance. So it's 20 and 23.25. So 20 is good because that's the offset. Nope. So 23.25, that might be a problem because I think this is supposed to be 20 from the center, but we'll work with it as it is. Okay. So now we're going to do another draft array. So we're going to go to draft, and this is going to be to draft copy this cylinder. So let's using our draft tool, we'll select the array. Oh, I didn't select an object, so there's my object, and it automatically arrayed it. So we're going to change this to polar, and change the number of polar to 3. And you see it's copied all the way around. It's, to me, I'm sorry, but it's like magic. I love it. So now what we're going to do is we're going to take our main body, and I'm going to union it with these two arrays, and then we're going to subtract out the third array. So I'm going to go into part and make a union of several shapes. So that's done. You can see these lines have disappeared because now it's a single shape. So now I'm going to take this fusion and subtract this array. So we're going to do a Boolean subtraction. And now we have all our through holes, and next we'll be working on this nut axis here. The next piece we'll add is the cutouts or the openings for the hot end, and that consists of 2 cylinders. So we're going to move back to the Part Workbench, and we're going to start with looking from the bottom, which, let's see, that's, I can never remember, 3, 6, 2. Nope, 2 is top, 5 is bottom. Okay, someday I'm going to memorize those. So we're just going to add 2 cylinders. We're going to start with the cylinder that the first cylinder, and this goes all the way through. Its radius is going to be 6.5 millimeter, and you'll see that it's 10 height. You could leave it at 10, but I'll make it 8 so it's symmetrical. And then we're just going to remove that part from the center. And now we're going to working from the bottom again. And this is because we were going to cut out a pocket that stops. And so this cylinder is going to be 8 millimeters in diameter, or in radius. And the height is going to be 6 millimeters. So it's going to leave a 2 millimeter ledge. So you can see that's where it's going to end. So now we can subtract that from the whole body. So the hot end will push through to this lip, and then only the threaded part, or only the filament receiver will go through. The next piece we're going to add is the 6 mounting holes for the effector retaining clip. So we're going to use a cylinder for that. It's going to be a radius of 1.75. Okay. And it's going to be offset by 12. It's going to be offset in the Y direction by 12.5. I think that's correct. And then we're going to create an array out of that. So we'll be able to use the drawing array tool, or draft array, I'm sorry, to create our array. And we'll change that to polar, and we'll change the occurrences to 6. And so there we have our mounting holes, and they look. Finally, to complete the part functionally, we want to add nut capture cutouts here. So you'll see I've selected this plane, and I've already set the working plane to that. So we're gonna just make this disappear so it's easier to work with, and we're gonna be drawing a polygon right at this center point. So I'm gonna pick a polygon, and I'm gonna snap to the grid, and we'll change the polygon to 6-sided. Okay. Let's check to make sure that's in the right spot. Yep. So you can see it's in the right spot. And let's change the radius to 3. All right. And you can see that's not quite centered, so we'll have to we'll have to fix that. That's okay. So now we're going to copy this polygon, and I should be able to paste it right here. So we're going to have a second polygon. We're going to make this radius 2.9, so we just want it a little bit smaller. All right. So, and then this polygon we're going to offset in the. I don't know how I did that. Let's see if I can get rid of it. Oh, I made a giant polygon. Okay, I couldn't figure out. That's really funny. So now the final thing we need to do is offset this polygon by 3 millimeters into the object. So I'm going to hide this up. So now we have 2 polygons, and we're going to be making a sweep with those, but I want to move this polygon in by 3. So we're going to try selecting this plane and making that our working plane. And now select this polygon, and we're going to try to move it by 3 millimeters in that plane. So I'm going to do move, and select the starting point of the polygon as just anywhere on this polygon is fine, and then we'll just move it in. I think if we do it in the global X and put -3, and let's check to see if that did it. Yeah, so we're able to move it 3 millimeters in. So finally we're going to create a sweep of this. So we're going to select the one. Let's go to part, and we're going to do a loft. Sorry, I always say sweep. And we're going to do polygon to polygon 1, and click OK. And now we have basically our wedge-shaped polygon. So it's the full size of the nut, and then it's slightly smaller, so it tightens it on it as you push the nut in. Okay, so now we're going to create a copy and a polar array of this. So as you can see, this polygon is not centered, so we need to select the loft. So we're going to center the loft, not the polygons will stay where they are, and you'll see what happens. So I have everything unselected except the center snap tool. So with the loft selected, we're going to select move and highlight the loft, select that center, and now I'm going to select the cylinder as the center, and you see that just the loft moved. If we take that away, you see the loft moved and not the polygons, so we're going to hide those polygons, and then we're going to change the loft to solid, and that should, so now we have a solid loft. And let's bring back our main shape. Now before I subtract this, I'm going to copy the loft. So I just want to go to the part workbench and select part, create simple copy, and then we're going to transform this, and let's see if it's going to be it. Yeah, okay. So this is going to be an easy transform, so I'll do this. So we're going to do, oops, sorry. All right, I'm getting in navigation hack here. So let's rotate it 180 this way, and that should take, oops, too far. I don't know what I did there to screw up my nav. Okay, and then we'll just move it up. Click OK. Good. So sometimes, boy, it just the translate tool makes it super easy. Sometimes it makes it harder. Okay, so now we have both of our lofts done. So now we're going to do 2 arrays from these. So to do our 2 arrays, we'll switch to the draft mode again, and with the loft selected, we'll do an array copy, and it's going to be, we're going to again set the type to polar and the number to 3. This is probably starting to become familiar. You see we got one there and one over there, and now we'll select the loft. Was that the loft? No. Okay, so that was. Okay, so now we'll select the copy and do another array, and it's going to be also a polar array. So we have our loft arrayed around on both sides correctly. So now we're going to Boolean away the loft. So to remove the material, we'll select the main body and the first array, and we have to go to the part workbench, and we'll make a cut. So there's our first nut capture, and now we'll select the resulting cut and the other array and make another cut. And then there's our other nut capture. So the final thing to do is just to chamfer the edges. So to chamfer the edges, I'm in the part design workbench, and I don't know why, but I like to select one edge. So I'm going to go into fillet, and I'm going to select all my outer edges. Sorry, this process is going to be boring for you. I have to leave it in because my video editing skills are not there. Okay, so now I'm just going to check all the edges, all these, and I'm just going to do the outer edges, and we're going to do a fillet of 3. Now you can just type this as well. I do like the part workbench fillet better because it changes as you do it, so you can see it. And there's our fillet. So you can see how this kind of just gives it this nice finished look. Now I would have liked, in my other designs, I had this went all the way to the corner. I'm not going to bother doing that. This is just a demo. This is probably fairly close to being able to be printed, but I think it needs some tweaking. So the final thing I'm going to do is I'm going to make a tech drawing of this to see how the measurements ended. So to do a tech drawing of this, we're going to go into the Tech Draw Workbench, which is a new workbench, and it's a little buggy. I've had it crash more than once, so I'm going to save before I do it. I'm going to create a new tech drawing. I'm going to select this fillet and add that to the drawing. And you'll see it'll give me an overhead view. And the reason I want to do this is I want to measure how we ended up distance-wise on these two because it should be 39.86. So that's good enough because it's 3D printing, so clearances are good. So this offset should be, I think, 20, because you need that for the firmware. So if this is not 20, it won't work. All right, so that's wrong. So so this drawing would need to be tweaked for printing, but this was just a tutorial on how to do it. So for example, if you look at, or it might be, oh, you know what it is? I think it might be from here to the center point. Nope, that won't work either. Yeah, so the offset ended up being 25, or no. Let's try one more. So from the center, that'd be a weird measurement, to the center, and I think that's the center of, no. So this is your final version. You probably could use this for 3D printing. You have to get the measurements just right. I think this is close to 40. It's just under, but I don't think the offset I did correctly. So you'd have to get that correct, because that's a critical measurement for the Kossel. You have to have the distance from the center to the attachment point of the rod arms for the Kossel, and that has to go into your firmware. So unless you have that right, this effector, this particular one, isn't going to work. So you need to do some adjustment. But that shows you how to make it, or one way you can design it in FreeCAD. And I think it's pretty straightforward to do it in FreeCAD. It's not too bad at all. So if you like this, let me know, and please share my channel and subscribe. And I hope to do the carriage next on the Mini-Kossel, and I have some other stuff in the pipe as well. So thanks again. Have a great day.